Okay, so here we have example 5. Example 5 is write an equivalent expression, and we have 5 over u plus 8. And we want to rewrite it as an equivalent expression so that the denominator is u minus 3 times u plus 8. So we have u plus 8 already as one of the factors in the denominator. So that's already there. We don't have to remove or do anything to the u plus 8. But I do need to include a u minus 3. And in order to do that, I need to multiply u minus 3 in the numerator and in the denominator. So let's rewrite this. Let's say 5 over u plus 8. And we're going to multiply that by u minus 3 over u minus 3. Well, if we distribute the 5 to the numerator over here, I would have 5 times u minus 3 over u plus 8 times u minus 3. Now, we could leave it like this because even though these are reversed, that's okay. Remember, numbers have a commutative property when multiplying. So if they're reversed, that's actually the same thing. What we could do is distribute the 5 and say 5 times u is 5u minus 3 times 5 is 15. And then if you want to rewrite these the other way, that's fine. You can say u minus 3 times u plus 8. So this is the term that we would write up here so that we would have an equivalent expression. So this is my equivalent expression. Okay, so here we have example 6, and in example 6 we're going to be adding rational expressions, but we're going to have the same denominator. So the first expression is z squared minus 5z over z squared plus 4z minus 5, plus the second expression, 7z minus 15 over z squared plus 4z minus 5. Notice the denominator is the same. Both denominators are z squared plus 4z minus 5. Now, since the denominators are the same, I can just combine the two numerators. So in the next step, we're just going to write z squared minus 5z, and then we're going to add 7z, oh yeah, I did have the mark there, minus 15, okay? And all of that is going to be over z squared plus 4z minus 5, okay? So the plus sign here means I don't need to change anything. I can just rewrite it. So I can just rewrite this as z squared minus 5z plus 7z minus 15, and all of that's going to be over z squared plus 4z minus 5. And now I can combine like terms. So the negative 5z and the positive 7z combine to give me 2z. So then this simplifies as z squared plus 2z minus 15 over z squared plus 4z minus 5. And now I need to factor because I might need to reduce. In the numerator, I need numbers that multiply to give me negative 15, but add to give me 2. Well, that would be 5 times negative 3. So the numerator is going to factor into z plus 5 times z minus 3. 5 times negative 3 is negative 15, and 5 plus a negative 3 is positive 2. So there's my numerator factored. And my denominator factored, I need to find numbers that multiply to give me negative 5, but add to give me positive 4. Well, that would be 5 and negative 1. So my factors would be z plus 5 times z minus 1. 5 times negative 1 is negative 5. 5 plus negative 1 is positive 4. Now, notice z plus 5 and z plus 5 is both in the numerator and denominator. If you recall from multiplying and dividing rational expressions, we reduce this. This would reduce completely, and we would be left with z minus 3 over z minus 1, and there's nothing to reduce here. So this is our sum or difference. It's really the same thing, adding and subtracting. I didn't explain it earlier, but adding and subtracting are the same operation. The only difference is subtraction is when you're adding a negative, okay? So these are all very similar. So now in the next video, I'm going to show you adding and subtracting with different denominators. In this case, we had like denominators, and now we're going to have unlike denominators.